All right, guys. When we are taking limits and we are using substitution and we find one of those indeterminate forms, so that means that 0 over 0 or plus or minus infinity over infinity, we all know that we are using, or we should know, that we should be using L'Hopital's rule, which means that we should be taking the derivative of the top and bottom and then using substitution. So let's kind of talk through, like, how do we actually do this and get full points on the AP test? So the very first thing you need to know, I can kind of tell with part A that if I plug in a 1, I'm going to get 0 over 0. So I know this, but I do have to show it. So I need to show it by taking the limit of both the numerator and the denominator and showing that those values equal 0. So I say the limit is x approaches 1 of x cubed minus 1, and the limit is x approaches 1 of 4x cubed minus x minus 3. All right, so I don't need to explicitly say 0 over 0 because I just proved that the numerator and denominator are both equivalent to 0. You can still say 0 over 0, but I do need to explicitly say LH because that means I know that this is an indeterminate form and I do need to use L'Hopital's. Now the next thing I need to show, after I've shown both of these, so that's step 1. Step 2 is show LH and use it appropriately. So I need to say the limit as x approaches 1, and I need to actually derivate the numerator and denominator. So we have 3x squared over 12x squared minus 1. Now, after I have that, I can just substitute. So that's going to be 3 times 1 squared over 12 times 1 squared minus 1. And I get 3 over 11. Let's look at this next guy here. The limit as x approaches infinity of the natural log of x to the 5th over x. Now, normally when I'm doing infinities, I'm going to be looking at in behavior, but this one, it kind of presents itself in a funky situation where, like, that's not going to necessarily be applicable. Also, if I plug that in, let's show this, the limit is x approaches infinity of the natural log of infinity to the... We know that this guy is going to give us infinity. And same thing in the denominator. That's also going to be infinity. So we have a really big number of a really big number, infinity over infinity. First step shown, I know I'm using L'Hopital's. So let's actually derivate. Rewrite. We have the limit as x approaches infinity. Remember, the derivative of a natural log is to write it as a 1 over the argument. So we have 1 over x to the 5th in the numerator. Let me make that a little bit more clear. That is x to the 5th and not x times 5. And then chain rule means I need to multiply by the derivative, so 5x to the 4th. And then the derivative of the denominator is just 1. So I'm going to clean this up a little bit because that's going to be 5x to the 4th over x to the 5th, which is just 5 over x. And dividing by 1, don't need to worry about that. Now when I plug infinity into here, I get 5 divided by infinity, or 5 divided by a really, really, really big number. And so the more we split up 5, the closer and closer it's going to get to 0. So my value is going to be 0. Very, very last one is we're looking at the limit as y approaches 0 from the right-hand side of the natural log of y squared plus y over the natural log of y. Now, I know right here that, first off, we're using y, and that's fine because everything is in terms of y. Second off, I might look at this and think like, oh, well, I don't know about this guy right here. But I do know that if I think about what a natural log graph looks like, as it approaches 0 from the right-hand side, we're getting closer and closer to negative infinity. So I can still say the limit as y approaches 0 from the right of the natural log of y squared plus y. It's going to be negative infinity. And the limit as y approaches 0 to the right of the natural log of y is also going to be negative infinity. So that's also that indeterminate form. So that's my first step that I need to show. Take the limit of both numerator and denominator, and then I need to write that LH and actually derivate both of those. So the limit as y approaches 0 from the right. Similar to before, natural log derivation means it's going to be 1 over y squared plus y times 2y plus 1 all over 1 over y. Chain rule does not apply there because, well, I mean it does, you just don't see it. The derivative of y is just going to be 1 with respect to y. So let's move this down a little bit. I now know that I can kind of simplify this out a little bit. I'm going to rewrite this as 2y plus 1 over y times y plus 1 times y over 1. So instead of dividing by that fraction, I multiply by that reciprocal. Those y's are going to cancel out, and I get 2y plus 1 over y plus 1. When I substitute 0, I get 1 over 1, which is 1. And we are good to go.